So we were discussing the differential equation, and almost we arrived at a closure. So where we have to discuss different problems from different exams, previous year exams. But last one, Euler's method, I want to tell you, Cauchy-Euler's method. Uh, Cauchy-Euler's method for a differential equation of a very particular type. And what is that type? The equation will be like this: x squared d2y by dx2 plus x dy by dx plus y is equal to 0. Suppose this is the differential equation. So you can see that the power of x and the order, they are same. Here it is 1. So this is also kind of 1, first order differential equation. And here it is 0, so derivative is also 0. Okay? Clear enough? So for such type of equation, what we have to do, for such a type of differential equation, we have to make a transformation. For such type of equation, we have to make a transformation, and that transformation is given by this: x d by dx will be our new operator, that will be some d by dz, and that I will denote by d. And this operator will come after we substitute x is equal to e to the power z. So you can go in the details by yourself, but this is what the substitution is. So clearly this is a transformation between x and z. So that means in our new equation no x will be there, because now x has transformed to some z using this relation. Okay, so when we write it, when it is square, it becomes dd minus 1. ध्यान से देखना, when it is square it becomes dd minus 1 plus, this is only one time, so it will be d, and plus 1 into y is equal to 0. Now this has become our well-known form of equation that we can easily solve. So by this substitution, our equation is transformed into a very simple equation that is given by d square minus d plus 1 into y is equal to 0, and this we can solve because this is our well-known equation. We can solve it. How to solve this? So you will get the value of d as 0 plus minus iota, and y will become a cos of z plus b sine of z, because now your new operator is in z. So this d operator is actually what? d by dz. पहले क्या होता था? d by dx हुआ करता था. Now it is d by dz. So this is our equation, but we want solution in well-known form of x because this is the original equation. So I will write a cos of log of x plus b sine of log of x. So this is the final solution. Please check this. So we have been asked about this solution, and you can't do, because see, this is not a constant coefficient, but the coefficients are some functions of x, a very particular type of functions of x. So please remember that we can't discuss the differential equation randomly. I mean any coefficient of x multiplied by y, that we can't discuss. We have to discuss that case by case. Okay, so this is the case which I wanted to discuss. This is known as Cauchy-Euler's method. Is that clear?
सर इस मेथड में हमेशा सेकंड ऑर्डर होमोजेनियस इक्वेशन होगी.
No, that is not necessary. See, the equation is transformed already, na? So if it is not homogeneous, then you will have to calculate the particular integral. So let me take that case also, na, to make it more clear. इतना clear है सबको?
Yes.
Can I erase this? So let me take one more case. X squared d2y by dx2 and then minus 2x dy by dx and minus 4y is equal to x to the power 4 is equal to x to the power 4. So this time right hand side is not 0. So it is not homogeneous. Na? It is a non-homogeneous equation. But that rule is still applied, that we can substitute x is equal to e to the power z, and then my equation will become d by dx will become d by dz, and that I am writing as an operator capital D. So now this will become d minus 1 minus 2d minus 4 y is equal to x has transformed now into e to the power z. So what I will write this side? E to the power 4z. So this will become d square minus d minus 2d. So let me write it like this: d square minus 3d minus 4 y is equal to e to the power 4z. So this onwards is your normal equation which you can already solve. Correct? So solve this. How it will become? It will become d square minus plus d minus 4d minus 4 is equal to 0. So it will become d plus 1, and minus 4 if I take common, it will become d plus 1, and it will become d minus 4d plus 1, and it will become 4 and minus 1. So now the solution will be written as y is equal to c1 e to the power 4z, I mean complementary function, c2 e to the power minus z. This is the complementary function. And what about particular integral? That will be 1 upon d square minus 3d minus 4 into e to the power 4z. So it will become 1 upon 4 square minus 3 into 4 minus 4,
0, sir.
which is becoming 0.
Z.
So I will apply my formula. It will become 2d minus 3 into
Z.
x
Z, sir.
into z, sorry. Correct? And
E
it
power 4 Z.
e to the power 4z. So now apply 4. So it will become z by 5 into e to the power 4z. Okay? So now write the final solution. So it will be y is equal to c1 e to the power z is x. So x to the power 4 plus c2 1 upon x plus z is log of x by 5, and e to the power 4z is x to the power 4. This is the answer.
एक्चुअली में सर
हाँ भाई.
सर ये आपने जो निकाला पी आई
हम्म.
सर जेड अपॉन टू डी माइनस थ्री सर समझ नहीं आया.
ये अगर आपको नहीं आ रहा है तो आपको याद करना पड़ेगा कि आई टोल्ड यू that 1 upon f of d e to the power ax is equal to 1 upon f of a e to the power ax. याद है?
Yes, sir.
And if fa becomes 0, then what happens? It becomes x upon f
Differentiate.
dash a
Okay, okay.
e to the power ax. So in this particular case, I have to apply this. Correct? So this example is clear to everybody? Somebody was asking something? And if it is x cube d cube, then it will be d minus 1 d minus 2. If it is x to the power 4, it is d minus 1 d minus 2 d minus 3. Correct? You can see the derivation, but that will not be required. You can't derive this and use it in the question. This is a suppose 3.5 mark question, so only this much time you can spend on that. Okay?
So what you have said, if x cube d cube is there, then d minus 1 d minus 2.
Yeah. If it is x cube d3 by dx cube, then it will be d minus 1 d minus 2, where d is d by d z. Correct? Is that okay for you? Any doubt in this? This is very important form that is known as Cauchy-Euler form. Now I am discussing previous year problems from here and there that I am going to discuss. So let me take the first problem. There is a differential equation dx by dt is equal to x square. This is the differential equation, and it is given that x0 is equal to 1. X0 is equal to 1, and they are asking uh, the value of t where x becomes infinite. So they are asking that value of t. What is that value of t? So let us solve this equation. This is simple variable separable, and this will become dt. So if you integrate it, it will become x to the power minus 2 dx is equal to dt. Just integrate it. So x to the power minus 2 plus 1 upon minus, so it will become minus 1 by x is equal to t plus c. Correct? And x0 is equal to 1. So 1 is equal to 0 plus c. That means what is value of c? C is minus 1. So you have already got the solution. So let us write that minus 1 by x is equal to t minus 1. Correct? So x is equal to 1 upon 1 minus t. This is the solution. So they are asking at what value of t xt becomes infinite. So it is clear that at t is equal to 1, x becomes infinite. So t is equal to 1 is the answer. This is a previous year net question. So if I write here June 2019.
Excuse me, sir.
Yeah.
Sir, how t becomes 0?
Where has t become 0?
Sir, in the next equation, minus 1 is equals to 0 plus c.
So what do you mean by this? This is known as initial condition that is given.
Yes, sir.
So what is meaning of this? Tell me.
Okay, at initial condition t will be 0.
When t is equal to 0, the value of x is equal to 1.
Okay, sir. Thank you.
So it is given. So let me take the second question. Next question. That is x times dy by dx plus 1 by x y is equal to e to the power minus x, and y of 1 is equal to 0. It is given. How to solve this? This is also a previous
Linear
year
equation.
question.
Linear
So
equation.
this is a linear equation. Dy by dx plus 1 plus 1 by x y is equal to e to the power minus x by x. यही है. So what is value of p? 1 plus 1 by x. So what is value of integrating factor? That is given by e to the power integral 1 plus 1 by x into dx. So that is equal to e to the power x plus log of x. So it will become x e to the power x. Okay. So this is the integrating factor. So let us write the solution finally. Y into integrating factor is equal to integral q into integrating factor into dx plus c. So y into x e to the power x will be x plus c. Apply this, y1 is equal to 0. So the value of y is 0, na? So 0 is equal to 1 plus c. So c is equal to minus 1. So y will become x minus 1 upon x into e to the power minus x. This is the solution. Okay. So this is simple linear differential equation. Linear differential equation of first order. First order. So see, the role of boundary condition is very important to get the constant. Okay. 2x du by dx and plus x minus 1 u minus 1 u is equal to x square e to the power x by u. X square e to the power x by u. This is the question, and we have to solve it. Okay. एक बार मैं फिर से चेक कर लेता हूँ. What is the question? 2x du by dx plus x minus 1 u is equal to x square e to the power x by u. Okay. So this is one of the previous year's questions from JNU. So can anybody tell in which category this will fall?
लीनियर इक्वेशन से 2x से डिवाइड कर देंगे.
अच्छा, तो आप बिल्कुल भी
No,
ध्यान से
sir.
नहीं देख रहे हो.
No, sir. U is there in it.
ये दिख रहा है?
Bernoulli's
So
equation.
this is Bernoulli's equation. Bernoulli's equation. So if you remember, in Bernoulli's equation, I told you 1 upon y. Here y is u. Y to the power, and what is value of n? So this u will get here. So I told you here it was y to the power n. So what is value of n? N is -1. So 1 upon y to the power n minus 1. It will become this is equal to z. This was the substitution to make it linear. So that means u square is equal to z was the substitution, and this equation will be changed to dz by dx, if you remember, plus p p 1 minus n, that will become 2z is equal to 1 minus n into q. Q is x e to the power x by 2. This is your new equation in the form of z. सबको याद है ये फॉर्म? dz by dx plus 1 minus nz is equal to 1 minus n pz is equal to 1 minus n q. And what is the substitution? 1 upon y to the power n minus 1 is equal to z. So now this equation is linear equation and we can solve it. 2 and 2 will cancel here. 2 and 2 will cancel here. So let us solve this equation. So first step is calculation of integrating factor, that will be given by integral 1 minus 1 by x dx, which is equal to e to the power x minus ln x. So ये क्या बन जाएगा? E to the power x by x. Correct? And can I erase this now? Upper part? I think this you have noted down. So what will happen? Y into integrating factor is equal to integral z into integrating factor by c. So it will become z e to the power x by x is equal to e to the power 2x by 2 plus c. And now it's time to write z also. So u square is equal u square into e to the power x by x is equal to e to the power 2x by 2 plus c. So this is the answer. So I am taking another question, which is 2 times u plus mu plus 1. Mu देख के मत घबराना. d mu by dx minus 2 by x mu plus 1 square is equal to x to the power 4, and mu of 1 is given as under root 2 by 3 minus 1. This is the question. So first order differential equation is there and we have to solve it. So you can see this mu plus 1 is creating a problem. ना? यहाँ भी है, यहाँ भी है. तो क्यों ना इसको सिंपल कर लें. mu plus 1 को y ले लें. So my equation will become 2y, and what will be d mu by dx? dy by dx minus 2x y square is equal to x to the power 4. And if I divide it, it will become dy by dx minus 2 by x, 2 will be cancelled, minus y by x is equal to x to the power 4 by 2 times y. So what type of equation is this?
Bernoulli.
Bernoulli's equation. So from here you can do.
Yes.
Can I give this as a homework now? Because the only thing was this, to recognize that if constant is added, no problem. You can just to take y, and if you differentiate it, d mu by dx, then it will be simply dy by dx. So after this, the value, write y as this -1, value of n is -1, and then you can proceed and find out the solution for this, and finally apply the boundary condition to get the value of constant. So this will be your homework. Okay, so I have discussed almost all type of questions, but you can also practice for yourself and ask if there is any doubt. But just, I hope you got the sense of what type of questions to practice. That is very important. See, in preparation you have limited time, and syllabus, if I call differential equation, you will find many books on differential equation. But we have to be very very precise. मैं भी किस हिसाब से पढ़ाता हूँ, seeing the 10-year questions, teaching from so many years, different exams. So I have just made a periphery that what type of topics I can cover, so that you can solve all possible questions from the exams. Okay, so that is the idea. So okay, then thank you so much.